Greetings. Welcome to our presentation on wood light frame construction. There is a lot of content to this particular topic, more so than the past topics. I would say there are a lot of pieces to the puzzle when it comes to rough framing. What we're going to look at today quickly is a quick review of heavy timber framing and the transition to light wood framing, which we've begun to discuss. There are two variations in light wood framing: the balloon framing when it was invented in the early 19th century, and then after World War I we transitioned to platform framing, and this is the type that we use today. We're going to discuss a couple of extra points about foundations. We were focused on the structural aspects and the concrete kind of formations that foundations take, I would say. In this lecture we're briefly going to touch on some of the other components that accompany a foundation as we move up to the frame. We'll talk about building the frame and a couple of variations on different wood frame construction, and we'll talk about the advantages and disadvantages of each, and then we're going to run through many different parts, a lot of different definitions that you should be familiar with. Okay, so heavy timber framing we covered quite extensively last week. So again, it required skilled timber rights and involved a lot of complicated joinery that held these heavy timbers together. Then it transitioned into the braced frame, which had the big heavy timbers, sometimes with metal connectors. And then it transitioned into, and at that point, the small dimensional lumber with the brace frame, the small dimensional lumber was being used as infill, and then the whole big frame was removed and we were left with balloon framing. That's the early variation, and that's where we have the studs running past this just a single story. So the studs would be 2-story height. And then we move into platform framing where we are today, and we'll take a closer look at that momentarily. Alright, so balloon framing, here we're looking at the outside of a house that's had its exterior sheathing taken off, all of its exterior finishes. This is a chimney, I would believe. And here we see the studs reaching from the foundation down here all the way up to the second floor. So a North American invention, circa the 1830s. Again, we discussed heavy timber framing, and in contrast, this light wood framing now, small dimensional lumber, simple nailed connections, required less skilled craftsmen. The technologies that were necessary to have this dimensional lumber framing working, we needed water or steam powered sawmills to cut the timbers. We needed machine made nails to make all this fastening, the many pieces make the fastening doable, and we needed railroad transportation to to get the materials out, essentially. So a big change from where it was with the timber frames, which were essentially being the timbers that would be cut down on your own property and hand cut. And then yes, continuous height, full height frame, as we said. All right, moving on. Here's two more images of the balloon frame. Here we see the studs extending past the second story, and here, just in a wall detail or a wall section, we see the stud sitting right down on the sill plate. So there's our foundation, our sill plate. The joist is resting on the sill plate, and the stud is extending all the way up from the sill plate all the way up to where it meets the ceiling rafters. Okay, and now where we are today, we have our platform frame. So we have inserted here the second floor, essentially. So now we have the sill plates are sitting. First we build our platform here, joist, rim band, and then when the platform is complete, we go up and we build our first story studs. Then the second floor platform is put on, followed by the second floor studs. So different from the balloon. So easier to produce, handle, and erect. A lot more smaller pieces, but more manageable and quicker. Another image of the same, so our balloon and our platform there. And here they are raising a balloon frame. So the balloon frame is all but obsolete, very rare, but the conditions where you typically find it would be In a two-story foyer, for instance, you would refer to that as being balloon framed. All right, and here's the platform frame. So basic, very simple concept. We have our foundation in, then we build the first platform, put up the first story walls, second story floor, second story walls, and upwards to the roof, to the roof rafters and the ceiling joists. And then in 3 dimensions exploded. So nominal 2-by-inch members. So this is dimensional lumber. Our 2-bys, 2x2, 2x4, 2x6, 2x8, spaced at 16 or 24 inches in parallel. Typically say spaced 16 or 24 inches on center, running parallel to one another. So here are joists running parallel to one another, and they would be spaced 16 or 24 inches on center. And that 16 and 24 works with the 4-foot by 8-foot sheathing that gets put down on the walls and the subfloor. So everything is in an increment of 16 inches or 2 feet. And the pieces, we have our floor joists, wall studs, roof rafters, and then we have our subflooring and our wall sheathing and our roof sheathing. So those are the 6 primary pieces to the puzzle. Okay, moving on to foundation. So I know that was just a quick review of kind of the history of the timber framing, the balloon frame, the transition into platform framing. So next, I just want to circle back to foundations quickly and talk about some of the components that accompany the concrete foundations that we discussed last week, or the week before last, that would be. So typical residential scale or small commercial wooden platform framing structure. So our foundation, the points we make here, that the excavation is to at least below the frost line, as we have discussed. Cast in place concrete strip footing, that's what we see here, the footing down at the bottom, and then the foundation wall, typically 8 to 12 inches thick with an 8 to 10 feet tall. So a story we want down there to create a habitable space. Okay, moving on. And now we'll look at some closer details here. So there is the list on the left just runs through the different pieces. I'll run down it quickly. So first we have our anchor bolts here. These are cast into the foundation, and the pressure treated sill for the frame that will be coming above, the platform that will be coming above, would be connected. These anchor bolts will secure and fasten that pressure treated sill at this point. Steel reinforcing top and bottom, that's right here, these small 2 circles, and these two small circles as well. That's the rebar reinforcing that's been cut in section, so we're just seeing the end section view of it. Dam proofing we cannot see in this view. The next slide we'll see a couple of variations on that, but that would be an elastic membrane on the outside of the wall here to keep the moisture out. Crushed stone at the perimeter and the drain piping that's down here. So the drain piping is a perforated pipe that would run around the foundation at the location of the footing, and it would be enclosed or covered in crushed stone, and that stone would have a fabric over it to keep debris or dirt from settling in it. So the idea is that the water that's coming down, the rain or the water that's coming from the roof drainage system is coming down here, and we want to shed it away from the foundation essentially. So hopefully it will find its way down here into the rock bed, and then the perforated pipes will take the water away, preferably to daylight if possible, but at least away from the footing. And then the backfill, so here this is the hatch, the architectural hatch for earth. So this here would all be undisturbed earth in its natural state, and this area right here is the backfill. And then we have our foundation, footing, walls, slab, and it says putting the slab in could be done later. That's typically kind of a standalone component to the foundation. Okay, so that's a quick look at that. And now a closer look at the insulation. So a couple different variations. So insulation typically takes the form of a rigid foam insulation for foundations. That's the most common what I see, and that's represented right here. And there would be some sort of a protective covering for it as well, and there we can see it as well. Coming down to typically, often down to the bottom is where I typically see it. That doesn't appear to be the case here though. And then just another variation on that is rather than put the rigid insulation on the outside is furring out this wall by putting small studs at this location and then having batt insulation on the inside. And then another important point here is definitely insulating the cavity. So what we see here is the joist running over, sitting on the pressure treated sill. There's the subfloor, and this would be the floor joist cavity, I would call it. In between two joists there's a bay, and at the end of that bay, down the end here near the rim board, you'd call that the cavity, and that cavity should be insulated. Okay, moving on. So just some images now. Anchor bolts we see here in this foundation. There are anchor bolts, kind of faint, but we could see them. The structural engineer would specify what size bolt and the spacing for it. Pockets for setting beams we see over here where the shadows are cast, so girders would be placed into those beams. And finally, for foundations, just an image of the insulation being installed at that location, and then we have our anchor bolts again. Looks like a excavation for a footing here in the back. Okay, moving on. So there was a quick review of the components that accompany a foundation. Moving on to the main event here is building the frame. So a lot of information. I'll try to move through it pretty quickly, but thoroughly. Okay, so frame construction, also called light construction, it covers rough carpentry, which involves the framing, the sheathing, and the subfloors. That's really what this whole chapter is about, and that's what rough carpenters, you'd call them. Yeah, specialize in rough carpentry. That's really what they would cover. So they deal with dimensional lumber. That's our 2x material. And we note here nominal versus actual, which we pointed out when we were looking closely at wood products. So 2x4, 2x6, 8, 10, and 12, and 4x4s. These are the most commonly used dimensional pieces. This chart here, looking at it quickly, I don't see a difference between this top part and this bottom part. The only addition they just add here, so number 2, spruce, pine, fir. That's a wood category that a structural engineer would specify, and then that in that category you could find these size pieces of lumber: 2x4, 2x6, 2x8, and then the lengths that they come in. So there's really no need to have a 20-foot 2x4. It would never be installed in anywhere. So otherwise, plenty of variety. And then just quickly to point out, which is important, is you could get pre-cut studs as well, and they come at various lengths. And the idea is that this 92 and 5/8 would have a bottom sill and a double top sill on it, and we'll see images of that shortly. And that would bring you up to the 96 inches, which is the 8 feet. And all this is in the effort to put an 8-foot piece of drywall in the living room. So the pre-cut stud, the 92 and 5/8, plus the 3 sill plates will get you up to that 96 inches, and then probably a little leeway above that to fit the 96-inch piece of drywall. So that's where it all stems from, and it's a pre-cut stud, common. All right, moving on. All right, so this image we're going to see over the next many slides. We'll be looking at quite a few slides. This image will reappear and then reappear as they continue to construct it, so it's a pretty good diagram. So what we see are the sill plates. So here's our foundation. There's a window in the foundation, and then there's a the name is escaping me right now, but this like a culvert, maybe kind of like a culvert, to create to keep the earth away from the window. I'll have to think about what that word is. That one's escaping me right now. But anyway, the sill plate continues above that, and then the girders are the next piece of the puzzle that are put in. So here, the girder would be running right down the center. Right there, we see a column supporting it, a second column supporting it, and then the joists reach from the outside wall over to the girder. A common configuration for a commonly shaped, rectangular building. Like a lot of residences, we'll have a girder running the length of the building, and then the joists will come in from both directions and span to that girder. And then the subfloor is applied here at the top. And typically the subfloor is applied perpendicular to the joists. It's almost always. I can't think that it would ever not be when it comes to the subfloor, but as we'll see some images moving forward, sometimes wall sheathing, it will be installed not perpendicular, but putting it in this fashion gives you the most rigidity. This is the best way to do it. The long joists are running in the short direction of the sheathing or drywall that pertains to as well. All right, moving on. So just another image of the same. So, oh, sorry, I moved this when I was looking at it earlier. So let's just look at this part on the left here. There we are. So the components again. We have our foundation, girder running below. So here's a pier. That vocabulary came up when we were talking about foundations. And so this is a pier in a crawl space setting, a small concrete column. That's what you would call a pier. The girder's running across, and the joists in this situation are sitting on top of the girder. That's one scenario. Another scenario is where the joists are ledged flush with the top. The top of the joist is flush with the top of the girder. That's a second common scenario as well, and we'll see that variation. And then the sheathing is being put in. And then we have solid blocking, another important part of the puzzle. So in between the joists over a girder, there's often or almost always solid blocking to keep the joists rigid. And sometimes that bridging is also put in mid-span here. Okay, and then here they have what they call the header joist, or I would call possibly a rim board. So the joists need to be wrapped at the end. Okay, moving on. I'm going to skip this detail. And moving on with my frame again. There we are. Okay, so the sill plate here in this situation is slab on grade. Well, actually I shouldn't say that. I can't be certain. This is kind of washed out. This could be a foundation wall, and that could be sheathing. It appears to be more like a slab on grade to me, but I can't be certain. Either way, this is a extra big 3-inch pressure treated sill plate. So this is not your ordinary 2x sill plate, and it also has the spacing of the anchor bolts very close. So this is a heavier duty application. Okay, moving on. So here's our some views of a girder. So here we have an engineered girder, engineered lumber, a laminate or something. I can't exactly tell by looking at this particular image. So it's coming over, and then it's anchored and ledged with this beam as well. And these joists are mounted flush with the top of the girder. And so that was in contrast to what we saw over here, where we see the joists running over the girder. This makes sense in a crawl space application where you don't care about the space below. But here in a basement or a habitable space where the headroom matters, and you don't want to have this large girder sitting 16, 18 inches below where you'd have to duck to walk under. So that's when things are put up flush. So more work to do it this way, but you get preserved headroom. So this is an engineered variety, and then over here is a built-up variety. So I can't exactly see what that says, but commonly 3 2x12s would make up for a built-up girder, and then all the joints would be staggered where these meet. They would typically be staggered, preferably over columns. And there we see a pocket in the foundation wall to accept the girder. And then here, it's not perfectly clear, but the top of the girder is probably should be flush with the top of the sill plate so that the joists all just sit nice and flush on top of them all. Alright, moving on. So wood joists come in a number of varieties. So this is all dimensional 2x lumber. Here we see the joist running over the top of the girder, easy installation. And then we have the blocking over the girder to keep the joists rigid. Here we see the dimensional lumber flush with the top of the beam, and we see joist hangers wrapping around. So the joist hanger would be put on kind of at the same time, and then the nailing could be finished afterwards. Okay, here we have eye joists. So we talked about this product quickly. So we have the OSB, kind of the strands of lumber here all laminated together that form the web, and then typically a solid piece for the flanges at the top and the bottom. Very light. One carpenter could pick up a beam this big, very, very light, and then there's a solid dimensional 2x here at the rim to secure them all. Alright, and then finally trusses. So this is made up of 2x dimensional lumber, typically 2x4s, sometimes 2x6s. So again, we have a top chord, bottom chord, the triangles or triangulated panels in the middle, and then those are put together with a hydraulic press that fastens these gusset plates. And these should never be cut. These are designed by the the structural engineer would provide information, or the architect would provide the information to the truss manufacturer who actually designs these, provided a lot of different varying information that they need, and then it's brought to the job site, custom built just for this. And the point I was getting at is that they should never be cut or altered. I once worked on a job where a plumber actually cut one of these webs out, and the whole truss we had to remove after the fact. We had to come back, take the plywood sheathing off of the outside, cut all of the nails free, and then take the truss out and replace it actually. So no altering trusses is the moral of that story. Okay, moving on. Moving on to so these are just some more details of what's happening at the connection at the foundation. So they're anchor bolts, sill plate, and joists. So here the joists are coming at us and cut in sections. So an important point on this slide, very important point, is that here we see an X through the joist. That tells us that it's a continuous structural member. And here we have a piece. So here's a joist, not coming at us. We're not seeing this in section. It's running in this direction over the sill plate, and it's creating this cantilevered condition. And here is a structural rim board at the end, a continuous structural board, and it has an X through it. And this is blocking, that is only running from this joist to the next joist closer to us, and it is not continuous, and that we know that because there's only a single line going through it. So structural rim board, non-continuous blocking, structural joists, structural rim board, structural sill plate, again another sill plate on top of an I-beam, and then this would be blocking sitting over the beam. Okay, and then subflooring is applied, and I think we're almost out of the platform here. So then just a couple more points on bridging. We see it being installed here. So this could be a crawl space condition, or they could be working on ladders, don't know. So the bridging, solid blocking is put in alternating from side to side so that the carpenters could fasten it. So again, on girders, and then also out in open space to keep them stiff. And a couple more varieties. So this looks like 1x material that's been cut. This is not common, not today. You'll see this in older houses, very laborious to put this in, cut all these angles and to nail so many pieces. More common, this kind of solid blocking, this is very common. And then for metal brackets. So again, if it's 16 or 24 inches on center, you buy the appropriate brackets. And then here with our I-beams, we have cut off pieces of I-beams that are installed as bridging. Okay. And then finally the subfloor, an image of that being put in. So here's a very strong subfloor adhesive that would be put on every joist top, and then the subfloor is laid down and then it is screwed off. So then again, the plans would specify the screws are every foot or so. Sometimes there's a spacing for the perimeter and then a spacing for in the field. Sometimes the perimeter here has to be closer together, and then in the field you have less. And the same goes for drywall. All right, moving on. Okay, so we finished our first platform. After this, we should start moving a little more quickly. We've reviewed all the floor components, and they just repeat when we get up to the second floor, essentially. So that's really the construction of a platform. All right, moving on, we have walls. So typically walls are constructed on the ground like this. So the carpenter would lay out the sill plate. That's our sill plate there, and that's our top plate. They would lay those out with rulers, identifying where the windows are, where the doors are, and then they would separate the sills, and then the windows, or all the pieces for the window construction would be laid in, and then all the additional studs would be laid in. Everything's nailed, and then it is stood up in place. And then when it's stood up, it has temporary bracing to secure it. And wall sheathing could be put on at this point. Sometimes it's put on the floor here, but it's heavier. If it's easy to access the outside of the frame, then the wall sheathing would just go on later, which it typically does. And this looks like a situation where the wall sheathing might have been put on prior to raising this. Looks like he's working with the brace. Looks like he just put this wall up, so my guess is the sheathing was put on and then the wall was stood, much heavier. And here it is. This is what it commonly looks like. So again, our bottom sill plate laid out. At the same time, our top sill plate is laid out. So that's the carpenters with tape measures and squares, putting all the information on both. Separate them, laying in the studs, putting in the window headers. These are called cripples above the window. This is the top sill plate. As it goes up, it will stand high, stand tall. Okay. And here we see bottom. So we're just running through the plates. We're discussing the plates here. So bottom plate right here, continuous plates right there and there. And then top plates are doubled right here. So we see two plates. So coming back here, the top plate is a single when the wall is erected, and then when all the walls are up and in place, then the second top plate is put on, kind of tracing out all the walls, and then they will overlap and tie them together. That's what this says here. The second top plate, the upper top plate, is the one that ties the walls together. Okay, moving on. Alright, so the parts of the exterior wall, we're dealing with the sole plates or the bottom plates, so that's right here. So here you have the sill plate that's sitting on the concrete, and then here you have the bottom plate that belongs to the wall, two different plates. Double top plates up here, studs here, headers over windows and doors, and then finished materials, and then sheathing as well. And that's what we see in both of these images. Okay, so most common scenario is the single bottom plate there, double top plate here. The plates match the thickness of the wall, so if we have a 2x4 wall, we have 2x4 plates, 2x6 wall, 2x6 plates. If the wall sits on a concrete slab, then that bottom piece is pressure treated. So here in this scenario, we do not have the concrete slab, that's down here. So right here, this sill plate would be pressure treated. The plate that belongs to the wall would not be pressure treated. But if this wall here were sitting on a concrete slab, then this would be pressure treated. Okay. And also just to mention here for the first time, we're going to get to it shortly, I know, are windows. So here we have a rough opening. So the window manufacturer will tell us how large this opening should be relative to that particular unit. Always want to leave a little bit of room so that the windows could go in level, which means here, and plumb, which is in the upright, and square. If a window is not in square and properly, it will not function properly. Same with the door. Okay, moving on. So how a typical wall layout would look. So here we just see a schematic of a very basic wall, and these dashed lines are indicating where walls are adjoining this one perpendicular to it. So on the outside wall here perpendicular, there's another wall obviously, and on the outside there's another wall here, and then we have an interior partition that's meeting the wall at this location. We're looking at, pretend we're looking at the front of a house. This is the right yard wall, this is the left yard wall, and then this is the wall that separates whatever, the the foyer from the dining room. So the walls meeting the exterior wall. So what the framers will do is mark all of those locations on the top and the bottom sill plates. Then they have to create certain framing conditions to accept those walls. So this is a corner post. So this is where an interior wall meets the exterior wall, and we're going to look at these in more detail. And another exterior post. And then the doors are framed in and the windows are framed in. So that's the next step on their list to do. And then the remaining studs are brought in all 16 inches on center. So that's starting from this outside location. So if we kind of flip back and forth, we can see where the voids are. Void, void up here, no studs, void, void, all void across here and void there. And then when we jump forward, we see we pull our tape measure here at 0, 16, 32 inches, 48 inches, and so on. This probably falls on the 16-inch increment, and then we keep going. 16, 16, 16 here, 16, and so on, all the way across. And that's so that the plywood, the 4x8 sheets of plywood, when they arrive, and the 4x8 sheets of drywall when they arrive, they'll have fastening, and the carpenters installing them will have the fastening members that they need. Okay, so this one, with all issues related to sustainability, very, very important, and reducing waste. We have here at the bottom, so up at the top, conventional, that's what we just reviewed. Here at the bottom, quote unquote, advanced framing techniques. So that's not a real term. It's not like a proprietary system or something. It's just framing techniques that are more thoughtful in terms of material waste. Producing less wood waste. So again, we just reviewed what happened up here, and this is supposed to be the finished product for the advanced framing technique. So the differences are where we typically have double studs here, or a stud and a king post here holding up the header. We take that out and we just simply have some sort of a blocking or something, I'm not sure what the detail is, that reduces this double down to a single. So we see that at all these locations. This must be a stud joining here. So this is a double or something, maybe even a triple, I'm not sure what's going on there. But basically reducing the doubles to singles. And then here, where that wall was coming in, and we're going to look at this in more detail. I'm going to jump back one. No, we're going to see it on the next slide. Where the interior wall meets, we have this kind of continuous studs to meet it. Here we get rid of the continuous studs and we make this kind of ladder instead. And we'll see this detail in the next slide, what we're trying to accomplish exactly. But kind of the moral of the story for me is, if it were my house, I would not take out these second members. I don't think this is providing enough rigidity, enough nailing surface, so I would not do that. What I do like about this bottom one is that everything is laid out on that 16-inch increment. So up here, where we first put in our doors and our windows, and then we had to come back and count every 16 inches to put the remainder in, it was clear that the doors and the windows were not laid out on that increment. Here, however, we have a 16-inch bay, I would call that, and then we found a 32-inch door and we put it right on that increment. and then again 16, 32, 48, and then we started our window, which again is 48 as well. So that I definitely appreciate, and if I were designing a house for myself, I would do that. I would not remove the double studs though. Okay, moving on. So this is the detail that we were just discussing, the corners and the interior wall meeting the exterior wall. All right, so at the corner we need to provide nailing surface for our exterior sheathing, being nailed here and here, and we have that here and here as well. So we're contrasting these two first. And then on the inside, we're going to have our drywall installed right here and right here. Drywall here and here. So we need nailing here and here. So this version, let me start with this. This is the conventional version. We have full height stud in the corner, stud, and then we have blocking, intermediate blocking. So if we had an 8-foot stud here, for instance, we might have 3 blocks, one at the floor, one at the ceiling, one intermediate one. So problems with this is it's more wasteful, at least the blocking is more wasteful. And what's worse about this really is that it creates a void that's very difficult to insulate. Where we don't have blocking here, we can't get insulation in very easily. Here, this is readily insulated. So this is a decent detail, I think. Coming over to this one now, we have the interior partition meeting the exterior. So in this version, we have full height studs, and then we have some blocking, and then we have a stud here to provide our interior corners. Insulating in here, again, difficult. So that would be a void, because it could be done from the outside before the sheathing goes on, but here we have 3 studs creating a void, so not preferable. Probably very sturdy and rigid. Over here, we have, rather than putting these 2 studs right up on this wall, we rely on the studs that are in place. So less wood, so that's a positive thing. And then we have blocking running from existing stud to existing stud. And then I guess it's kind of packed out here for some reason. I'm not sure why that would be, why the blocking just wouldn't be up against this. But we could insulate it, and this piece. This piece is continuous. That's why that would be there. So this provides us, so it's a 1x8, providing us continuous nailing surface in this direction. And the blocking is supporting that continuous board at probably again at 3 locations. So I think this is a fine detail. As long as this is rigid enough to accept the fastening for the interior drywall, I think this would be fine, and then it would be insulated quite easily. Okay, moving on. So windows, we discussed the rough opening already, and there's the window unit in place. So this image, a little kind of peculiar. I've never actually seen this one. So this is where the header here has been pushed up to the top plate, actually, and the cripples are below it. Typically that would be mirrored. I'm used to seeing the header, and these 2 boards put in here. So this is a little wasteful. These 2 boards don't really need to be here at all. If the header were down at that location and the cripples above it, yeah, I'm not sure what you're exactly buying with this in terms of like what the benefit of that is. And then here, so we have the jack studs on the side, and there's a lot of lumber. So we have a stud going all the way up to the sill plate here, a double stud supporting the header. So yes, it looks a little heavy-handed in my opinion. And then also we point out here to note that we have pressure treated down at the bottom. This lumber, we see the pressure treated yellowish sill down here. So pressure treated plywood as well to better resist moisture down here at grade level. And then we have the OSB up above it. Alright, moving on. So here is what the window looks like, and as I was saying, this is what I'm used to seeing, just a header. brought down. And so depending on the size of the header, it would say like all headers that are 4 feet and below could have a single jack stud here on the side supporting it. If they're 4 feet or above, then they need a secondary supporting stud on the side. These are the cripples, again following the 16-inch layout. And then here in section we see the same thing, the sill being cut, the sole plate or the bottom plate, the double top plate, and the headers. And the headers are 2-bys that are standing on edge, often with a spacer. So if we have a 3.5-inch wall, we have 2 2-bys and it's a spacer, typically a plywood spacer. Getting back to this diagram, so now we have got our walls up and we're putting our second platform on, which is really essentially a duplication of the first one. I mean, it could change, but it typically doesn't need to, in general, I would say. And continuing up, so here we are. So this is really a similar detail, just how these joists at the second floor platform are being supported on the walls below. So this was just, these walls are now taking the place of the foundation essentially. So the joist is coming over, sitting, bearing on the wall, and then we have our continuous rim board. Here we have an interior bearing wall coming over, and we have our blocking. Here we are looking at the opposite view. So here we have a section in one direction and a section in the other. Here we have the joists coming at us, so this end joist is sitting right on the wall, and here we have to provide some 2-by to nail our drywall ceiling up. Okay? And I do realize that materials, there are many other wonderful materials in the interior material library that designers use. I'm just referring to drywall because it's used 98% of the time. But hopefully we'll have time to get to some other interior material reviews. So I just use that as the kind of stand-in for everything else, all other types of paneling. Okay, moving on. So here we're just talking about eye joists, so really no new news except that sometimes we have stiffeners or squash blocks that are added to support at locations, at bearing locations. All right, and here another quick special topic that should be mentioned are in areas that are prone to seismic earthquake activity or hurricanes. We have to have additional tie downs. So in Philadelphia, for instance, we have our anchor bolts at the foundation, of course, and then we have our rafters that are tied down and our joists that are tied down with metal anchorage. But if you go down into Florida, for instance, and I've spoken to builders who have built there, it just adds tens of thousands of dollars to a project. That these straps, they have straps running from the concrete foundation all the way up to the rafters, and everything is just kind of held in by these members, but very, very expensive and very serious. Obviously, having roofs ripped off of buildings, very dangerous, obviously. So anywhere near hurricanes or earthquake activity, it's a much bigger deal. Here in Philadelphia, where the weather's pretty mild, less so. And then shear walls. So that was tie downs in the previous slide, and now shear walls. This is what keeps the building from racking, essentially. So resisting the wind that's blowing on the side of the building. Again, here in Philadelphia, the plywood on the outside would suffice to resist that. The frame without plywood could move pretty easily left to right and call that racking. Once you put the plywood on it, it will not do that. Again, in areas where that are high risk, you get into much more serious, bulkier shear walls, and that's what we're looking at here with this very intense nailing pattern. So this all comes from the structural engineer. The builders on site don't make this up as they wish. So the panel strength, the nailing pattern, and structurally how it needs to perform, this is all specified by the engineer. But anyway, important to mention. So back here, moving up. So now our walls, just like our first floor walls, coming up. And then we continue. We're up to the top now. Ceiling joists, our ridge, and our rafters are being dropped in. All right, we'll take a look at a couple of rafter details. So here we are up at the roof again. So stud wall comes up, double top plate. We see the sheathing on the outside. We have our roof, our ceiling rafters that are coming across. So they're not really a major structural player, except that they are holding up drywall. Typically the loads from the snow would be coming down on the rafter and then being transferred down into the wall. And then here we see collar ties. So one thing that these rafters do is push out. They produce lateral thrust, pushing these walls out. So these collar ties will be placed in the top up in the attic to resist that outward thrust. And the ceiling joists also help resist that lateral push outside. And then in this capacity here, I just want to talk about the ridge board. Ridge board, again, not really a major player. All these rafters are kind of just leaning on it and holding it in place. It's not really providing a lot for these rafters. Okay, I'm going to keep moving on, and that's in contrast to the next slide. So here is our ridge beam kind of being held in place by, or ridge board being held in place in compression, in contrast to a ridge beam. So here we have our rafters resting on the beam, and that's what we see here. And that's because we've eliminated the collar ties and we've eliminated the ceiling joists. So now these rafters would completely push out those walls, and that this board would not be doing anything. But now if we provide a beam up there and some fastening, now the beam is holding the rafters to it and not allowing it to put excessive outward thrust on these walls. Okay, moving on. So this is, we didn't really review, we're not going to have time to review all of the different architectural styles for roofs. There are many. Here, this is a hip where we have the roof framing resting on two adjacent walls. So there are a lot of complex roofs out there, suffice to say. All right. And winding down here, now we just see a couple roof trusses in place and the bracing to put them into place, temporary bracing here. So that all looks good. And I think that is it. We've come to the end. And then here's a fully sheathed structure, and finished carpentry work is on the eaves has begun. So these are our eaves. So this is the rough carpentry part here. Often also, though, the carpenters, the same crew of carpenters will put in doors, windows, exterior doors, that is, windows, and they will put tar paper on the roof. And that's called sealing it in. Then the envelope has been sealed, and then you start putting drywall and things inside. So that's an important stage that this building has not yet reached. Okay, so that was a lot of information, I know. Thank you for following along, and we will review soon. Thank you. Bye.